Students, this is lesson 6.6, the in-class lesson. So on my website is linked a short Pixar video. You want to watch that. It's only about 3 minutes long, and then make a comment. What 2 to 3 minutes long? What 3 new things do you understand about Pixar animation? 3 new things that you understand about Pixar animation. If you need to, pause this video, check that one out, and come back. So students, in that Pixar video, they talked about geometric transformations several times. Geometric transformations. And geometric transformations is basically the movement of shapes on a coordinate plane. And when you're doing computer programming and animation, you have to do it mathematically. You can't do it physically. So we're going to be talking about the very basics of how to move objects mathematically on a coordinate plane. So we're going to start with the most basic one, which is translation. I'd like you to say this out loud with me. Translation, or to slide, add to the left, add to the right. To slide, add to the left, add to the right. So translation means to slide. You'll see that in a moment. So we have these 3 points, -3, 0, that's C. B is going to be at -3, -2. And U is going to be at 0, -3. And we're going to slide this shape 4 units to the right and 3 units up. Now, since you're working on paper, it is possible just to physically bunny hop these points. Let's do that just with this 1 point. So 3 units to the right and up, or of course positive. Left and down, of course, are negative. So we're going through 4 units to the right, 3 units up. And that's going to be what's called our C prime. Problem with animation is you cannot do that physically. You can't move stuff physically in a digital world. It has to be mathematically programmed. So moving by sliding, all you do is you take your horizontal motion and add it or subtract if it's negative to the left, to the x coordinate. So we're going to add 4, add 4, add 4. And we're going to take our vertical motion and add or subtract to the right. +3, +3, +3. Let's get our 3 new coordinates this way. -3 + 4. You go ahead and do your own math. Now, plot your new points. Wow, looky there. That first one matches our bunny hop, which is 1, 3. If you've done this correctly, the shape is exactly the same shape. That's why it's called a rigid transformation, but it has slid, if you will, or translated 4 units to the right, 3 units up. To slide, add to the left, add to the right. We're going to do reflections. Reflections, to flip over the y opposite the x. To flip over the y opposite the x. So we're going to flip over the y coordinate. So I recommend you just darken the y coordinate. So we're going to take this image and we're going to mirror it over the y-axis. We get those three coordinates. And you can see here we're changing a horizontal motion. So to flip over the y, you're going to opposite the x coordinate. Opposite the x coordinate. Only the x coordinate. If it's 0, of course, you can't do anything with that. Let's plot those 3 points. So we have 3, 0. That's our C prime. And 3, negative 2. And 0, negative 3. We're going to close that up. And you see it's butterflied over the y-axis. Butterflied over the y-axis. So we reflected over the y-axis. Now we're going to flip over the x. And to flip over the x, we're going to opposite the y. To flip over the x, we're going to opposite the y. So darken your y-axis. We're going to take this shape and flip it that way. Notice it's a vertical motion. So because that's a vertical motion, we opposite the y coordinate. So yes, that's the same point. It's going to be C prime now. B prime. And U prime. And you have reflected or butterflied across the x-axis. So to flip over the x, you opposite y. These are reflections. We're going to reflect over the origin or rotate 180. You'll see in a moment that that's the same thing. To flip over the origin, you opposite both. To flip over the origin, you opposite both. So we're going to take this, we're going to go straight across the origin. Get your 3 points. And now we opposite every one of them. If it's negative, it becomes positive. And if it's positive, it becomes negative. Close it up. Now the easiest way to test to see if you got that right is choose any set of points. I'm going to choose the B points. Just darken them. And now just physically connect them with a straight line. You should notice when you do that that you have gone directly through the origin. That's how you know you flipped over the origin. I'd like you to try something else. Starting from B, I'd like you to sweep a rainbow. And you see that that's 180. So by rotating 180, you get the exact same image. That's how you know flipping over the origin and rotating 180 is the exact same thing. 2 more, and we'll be done. Now we're coming to the tricky ones, which are the rotate 90s. The rotate 90s. Right here, we're going to rotate 90 clockwise, switch and flip to the right. Say that with me. To rotate 90 clockwise, switch and flip to the right. Step 1, let's get our coordinates. Now, we didn't do two things. First, let's just physically look where we're going. We're going clockwise, which is that way around a clock. So it's nice just to take a light pencil sweep and tell yourself you're going to be moving the image that way, 90 degrees. You take this in 2 steps. Do not do this in 1 step. Step 1, you simply switch the orders. So -3, 0 becomes 0, -3. Do absolutely nothing else. Just switch. The next step is we're going to flip the signs by drawing a clockwise arrow. Flip just that sign on the right. Clockwise arrow, flip that sign, clockwise arrow, and if it's 0, you can't flip the sign. Go ahead and let's graph the new points. So that's going to be 0, 3. That's our C prime. -2, +3. That's our B prime. And -3, 0. That's now our U prime. And this rotation is kind of hard to see. It looks kind of like a reflection. So a way to test that is let's choose any set of paired points. I'm going to use B and B prime. Go ahead and just darken those. Now take a straight edge if you have one. From the origin, draw a line to B. From the origin, draw a line to B prime. Now ask yourself, does that look like a 90 degrees? Which it does. Second question, have you gone clockwise, the correct direction? And you have. So that's a good way to check, is just physically take a set of points, draw lines from the origin, make sure you've done 90 and you've gone the right way. To rotate 90 clockwise, switch and flip to the right. Last one. To rotate 90 counterclockwise, we're going to switch and flip to the left. To rotate 90 counterclockwise, switch and flip to the left. Get your 3 points. We're going to do this again in 2 steps. Step 1, you switch. Do nothing else, just switch the orders. Now we're going to go counterclockwise. So you draw a counterclockwise arrow, flip the sign. 0, there's nothing to flip. Counterclockwise arrow, positive, negative becomes positive. Counterclockwise arrow, negative becomes positive. Realize counterclockwise, we should be going that way. Let's do these 3 points. C prime. That's C prime. Let's see B prime, +2, -3. And U prime, 3, 0. Close it up. Once again, it looks kind of like a reflection, but it's not. Let's test it. Let's choose our B points here, B and B prime. Go from the origin to B and the origin to B prime. Connect them. Take a moment, you should check. Yes, that actually does look like 90 degrees. Check your direction. You did go counterclockwise. Do the rest of the worksheet on your own. Check your answers, work in pencil, check your answers in red pen, including the YALIX, in order to get extra credit.